As companies have started to use AI more and more, there comes a time when you realize that you're hitting your budgets, either your money budgets, your token budgets, or your token limits. And because of that, you need to pay attention on how to optimize the use of AI in software development. And this is what I would like to discuss today, 11 practical tips on how you can do just that. Welcome back to Think Design Work Smart. I'm Alex Bulbok and I'm coming at you from the Mosaic Work Studios. And what I have for you today is a discussion on how to optimize the usage of tokens in software development. So this is specifically about programmers using coding assistants in order to create code or other related artifacts like architecture, documentation, and so on. But some of these also apply to other parts of the audience. So it could be that if you are not doing code, you might find some useful tips as well, but it's mostly focused on code. First tip is don't use AI for everything. It might sound a bit unexpected, but that's really a good mindset to have. What I've seen in our trainings is that a lot of times people would generate, let's say, a Python script and then ask Claude Code to call the Python script and return the values. And I understand the temptation, I really do. But there are better ways of doing that. For example, running the script yourself. Another thing that I noticed is when you are repeating certain patterns in your assistant, in your prompts, and you realize that after a while, then maybe you could automate that. And so one thing that I like to teach developers who come to our AI-powered courses is to learn how to generate or to consider generating tools that they reuse. And this links to what we've discussed before. So you can generate tools like Python scripts or whatever that, let's say, they validate infrastructure or that validate code against specific domain constraints or whatever you need to. But I want you to start thinking about generating tools. That's really, really good. And then you can run those tools, again, ideally yourself, and thus avoid consuming tokens for things that you can do yourself. Small tip here, if you don't want to remember the commands for running those scripts, that's absolutely fine. I don't want to do that either. And I use a tool that's called Just, and Just files just for that. So check that out. Another thing that you should consider is solve some things yourself, right? Maybe the model generated an image. You asked for an image, it generated an image, but it's not precisely as you want to. Instead of instructing the model of changing it, you can just go and change it. I don't know, add a white background or something like that. Or if the code is not exactly like you want, slightly modify it. There are all kinds of things that you can do like that. So this would be the big mindset thing. Do some things yourself, call tools yourself, generate tools and artifacts and other documents instead of asking for the same information again and again, or instead of running the same commands again and again. A second category we can look at is prompt and interaction habits. Here, one of the easiest ones is to select the model that is fit for the task. If the task is really simple, select a smaller model. If the task is more complex, select a bigger model. And especially if you're doing sub-agents in Claude Code, you can specify which model to pick. in the sub-agent configuration. This is really good because it allows you to optimize the usage of tokens by using a lesser model when you don't need a bigger model. Of course, this will need some tweaking in time, but you can just do it as you move along and try it for various tasks and play around with those. You could also do some comparisons, like running the same prompt with two different models and see how they behave, or configure your sub-agents first with a lesser model and then with a bigger model. Only increase the model size when you need it, but these are details. It's how you can optimize in time. Another thing that is really useful is to ask for brief outputs explicitly. And the reason why this works is because output tokens are 3 to 5 times more expensive than input tokens. If you know how these models work, it makes sense, because for every output token, the model needs to make a pass through the model. And then the predicted next token is added to the initial input, and then you go on, add again the predicted token to the input, and keep moving like that. So they need iterations to give you n iterations to give you n output tokens. Therefore, one of the best things you could do is to reduce the output size. And one of the ways to do that is to ask for brief output. You can do that in Claude.md. If you're using Claude, you can do it in your settings in the chat, so that it's something that is there and you don't have to specify each time. Another thing that's really useful in this category is tell the assistants what not to do. Because, let's say, for example, you are looking at a piece of code or the code base. One thing you can tell them is, look at this file, don't look at the other file, or only look at files in this directory, don't look at files in the rest, or only look at files with a certain name, let's say controller or whatever, user. Don't look at payment files or at model files. We're just working on this. And this is really, really useful because it limits the information that's added in the context and actually in the input prompt, because that's part of the context, in the model, as an entry to the model, which means that you're reducing the input tokens used. And then maybe the most important one from this category is to work incrementally and clear context. So the way you can think about this is take a big problem, split it into smaller problem, start working on that, and for every task you generate an artifact, you then clear the context and you move to the next one while feeding part of exactly the context that you need, the files and the artifacts that you need into the next phase. And this, of course, if you take too small steps, it might not optimize anything because you need to bring in the files. But if you have too long conversations, again, it gets too big. And the cost increases because the history of your conversation is always passed completely into the model. So this means increased input size, input prompt. Therefore, what you can do is to structure your work such that it's done incrementally. And here examples would be, let's say, if you want to write unit tests. First, describe the problem for which you are writing unit tests and ask for a list of tests. Then, without actually implementing those, then you can clear the context and then you feed the list of tests. Say, given this list of tests, let's generate tests one by one or all of them, and then you review those tests, and then you can take one by one the test and say, okay, for this test implement the code, and that's how you can move incrementally. Of course, this is extremely simplified, and you'll need to find your own steps, your own increments. This becomes an art on how to figure out which are the small increments that optimize for interaction with AI. And remember to clear context, either by starting a new window or by calling /clear. Usually there's a command that you can call to clear the context, which allows you to move on as if you would start a new session. And then we can go to another category, which I call structural optimizations. This is interesting because these are ways of configuring various things in your system so that they optimize token usage. One example here is sub-agents with minimal context. So sub-agents are really good in Claude Code because you can configure them and you tell them what to load, what to use, the things that they can use, and so they only look at a small part of the context and they act like their own prompts. And as I mentioned before, you can also specify the model that you want to use depending on the task, so you have another way of optimization. This is really helpful for two things. One is reducing, having very small tasks. So instead of you clearing the context, the agents do that automatically, but also in better results because they only load what's necessary, which means that your context window is managed and you don't get outputs that are not great. You get the best outputs you could. Another option here is RAG for large code bases and documentation. If you find yourself working in multiple parts of a large code base, or like I had in one of my courses, one of the participants was working on migrating an application from older technologies to Java. And the question was, okay, but how can I understand the existing code base? But that code base, the advantage is that it's static. And so you can use RAG in order to do that. So basically what RAG means is you take documents or code, you split them into chunks. And in the case of code, you can think of chunks like a function, import statements, things like that. And then those are classified with a classification model, still a neural network, but not a large language model. And then you can perform semantic queries like give me everywhere where payment related stuff exists, and it will give you payment, it will give you card, it will give you account, it will give you bank, it will give you notions that are close to the notion that you are searching for. And what a RAG query returns is a list of chunks. And then if you feed those into a coding assistant, they can give you a story or a synthesis on those chunks. And this helps because instead of trying to look at the whole code base at once, which would increase the context window, so you'd get worse results, it would also increase the input prompts, so you'll get you'll have very costly queries. Instead of doing that, you can focus on specific things and say, okay, let's see how the payment process is implemented. You go to Claude Code. Claude Code is integrated. You integrate Claude Code with MCP to a RAG server and to the RAG database. And then you get the queries, they get integrated into the prompt. And so you are querying little by little from your existing code base and getting the better answers than if you are to try to load everything, which probably won't work. The same process can be applied for documents. So you have an architecture document, if you have technical documentation, if you have API documentation, maybe you have open API specs, maybe you have infrastructure automation like Docker Compose or Kubernetes or Docker containers or whatever. You can pass those through RAG pipelines and query the important stuff and kind of link things between various parts of your application. And if you're interested in how to do that, we can definitely help you. We've been setting up as a practical exercise in our AI-powered software engineering courses. We've been setting up RAG pipelines. Actually, I helped participants set up their RAG pipelines on code just to see how things are working. Of course, this is not magic, so you have to optimize certain things, you have to make certain decisions, but the usual engineering. Another thing here is debug agentic loop stop conditions. So if you're doing an agentic workflow, pay attention to when that workflow needs to stop. You don't want to hit the limits with those. You don't want the agents to go into an infinite cycle and consume all your tokens or hit and consume the token limits. So instead of doing that, you need to figure out ways to limit. So if you're implementing loops, maybe you limit the number of iterations. If you're implementing, and when you're calling the Anthropic API to get answers, again, maybe you optimize the output so that is as small as possible, and so on. So there's a lot of work that you need to do there and make certain that they don't do too much before making it, using it extensively, because they have a lot of ways to fail. Another two tips that are very interesting here is first, cache repeated content. If you're using the API, there are some controls there. You can specify what to cache roughly. But there's also automated caching. So one tip here is to have a Claude MD for your project, and in that Claude MD to store important static information about that project, because Claude MD gets cached. It's static content. It's sent in the beginning of every query. And so it will get cached by the system, which means that it will cost you roughly 10 times less than if you pass the same information in separate queries. So this is a very useful tip. And if you're using something else than Claude Code, research your tool and see what gets cached, how, when, and what are some optimization techniques there. And finally, another one, very interesting, batch, no real-time work. You can set up jobs that are batch jobs when you call the Anthropic API, which means that if you have things for which you don't need immediate output, you can instead specify, I need to summarize these 100 documents, but I don't need an immediate answer. What I need is to give me an answer and run these whenever you have capacity and give me an answer. And these are priced differently, these batch jobs. So again, check out the documentation of the tools that you're using and see how you can make this work for you. One thing that I wanted to mention, going back to caching repeated content, if your Claude MD needs to import stuff, to read external files. There are two ways of doing that. You can instruct include.md and say read that file, but that won't cache the contents of the file. But you can do you can use path to file to import that file as static content, which means that if, for example, you have project documentation that is stored in various parts, if you refer to it without, I don't know, architecture.plant.uml, then it gets included in the CloudMD file before being sent, which means it will get cached. So again, very useful tip. And finally, one last category that I want to discuss is observability. And here, what you can do is always measure, look at the logs, optimize. I have used Langfuse for that. It's a pretty nice tool. It's something that you can spin up in your own infrastructure using Docker Compose, and then connect your Claude Code to it, and then watch what is being sent to the API, the Anthropic API. So what's actually in your input, what is the output, how many tokens are used, what's the latency, and all kinds of stuff like that. And maybe you can look through those logs and figure out what else to optimize. Another thing here is, if you don't want to use Langfuse, which requires its own server, you can probably run locally something like Phoenix. Now, depending if you are in a large organization, in a corporate, maybe you'll need some additional rights to do that. Figure it out. But it's really worth it to have some kind of monitoring built into your system so that you can go there and check out for things like repeated patterns that could be skills, maybe. Things that could be done with sub-agents. Things for which you could generate tools instead of asking your assistant, and so on. So with this being said, these were 11 tips for developers on how to reduce costs with AI. I'm sure these are not the only ways. If you have even better tips or other tips, let us know in the comments. We really love comments. And apparently YouTube is loving comments more and more nowadays. So if you leave us a comment, based on what I've heard, this is better for the algorithm. I have no idea. I don't pay attention to the algorithm, but it's what I've heard from other YouTubers that I'm watching. And if you have questions on other things related to using coding assistants or AI in your workflows, let us know in the comments or contact us at mosaicworks.com and join one of our AI-powered courses. Right now we have AI-powered software engineering, AI-powered application engineering, AI-enhanced architecting microservices, but there's more to come. And don't hesitate to send us a message and ask for support. If you need support of any kind, we are building custom trainings for customers who want to solve their problems, and we have an amazing infrastructure to do that. With this being said, I hope this was helpful. Next video will probably be about AI assistants in architecting software, how to use AI for software architecture. I hope this is an interesting topic, but if you have any other ideas, again, let me know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.